Greetings to Puan Nurul Kausa, our lecturer for the subject Engineering Seminar 1, Coding BELR 2061. I am Leonard Anthony with the number matrix B1124101886. Today, me and my fellow groupmates will be talking about the water usage in steam turbines and the ethical management in water scarce regions. So, let me start off by talking about steam turbines. Steam turbines are mostly used in power plants due to their function of cooling and condensation, and they rely heavily on water. But in water scarce regions, which means in areas or places that have shortage in water, this would create a major problem, major impact, be it in social, environmental, or even in the engineering industry. So, that is why it requires sustainable water usage and long term environmental planning and adherence to professional codes and standards. So, let's go through the engineering technology challenges. First, we go through the cooling system design. Steam power plants typically use three types of cooling systems. First one is the once-through cooling. This type of system withdraws massive amounts of fresh water, and there would be a high thermal discharge as they release the water back into the ocean. Next, we have the closed-loop cooling, which are the cooling towers. This is one of a system that greatly reduces the water withdrawal, but it still requires a significant makeup of water. And lastly, we have the air-cooled condensers. This type of system drastically reduces water usage, but it also reduces the turbine's efficiency in hot climates. Next, we will talk about more of the other challenges. First, we have water quality engineering issues. Corrosion in boilers, condensers, and pipelines, scaling from calcium and magnesium salts, fouling from biological growth, and the need for chemical treatment. And next, we have the thermal efficiency versus water consumption. Higher cooling water temperature lowers the efficiency, and there would be a trade off between power output and water availability. And lastly, we have infrastructure's limitations. Older plants are not designed for water scarcity. Retrofitting costs are extremely high, and it requires engineering innovation. So, next, I will pass to my friend Arif to talk about the sustainable development impacts. Thank you.
Hello, my name is Arif Rahman. My matrix number is B11241017. I will be talking about sustainable development impact. So the positive impact is efficient power generation. The point is water as a steam is the working fluid that drives the turbine blades. The second one is renewable energy and abundant working fluid. So the point is water is relatively cheap and widely available. So the third positive impacts are better thermal efficiency. High pressure, high temperature steam increases the Rankine cycle efficiency. And the last positive impact are cooling and condensation benefit. Water is used in condensers to cool exhaust steam. That's all from me. Thank you.
Hello, my name is Muhammad Aizat bin Abdul Aziz alias Sahirin. My metric number B1124101169. I will explain about the negative impact. First, high water consumption. Power plants require a huge amount of water for steam generation and cooling, can cause stress on local water supply, especially in drought area. Secondly, environmental impact. Large water withdrawal effect ecosystem can reduce water availability for agriculture or communities. Lastly, thermal pollution. Discharge of hot water into rivers or lakes after condenser cooling can harm aquatic life.
Hello, my name is Muhammad Irfan Zekri, and my matrix number is B1124101191. So, for section 4.0, I'll explain the professional ethics and norms related to water usage in steam turbine system. As engineers, our responsibility isn't only technical. We also need to protect the public and the environment, especially in the water-scarce region. And the next slide is about relevant professional codes. So the Malaysian Code of Professional Conduct highlights two key clauses. Clause 1, engineers must prioritize public safety, health and welfare, meaning our design must not threaten community water supply. And the second one, engineers must approve only designs that meet environmental and safety standards. So ethically, we cannot design system that overuse or damage water resource. For the next slide is ASME ethics, ISO 14001 and local regulation. The ASME Code of Ethics requires engineers to minimize environmental harm, including water usage. ISO 14001 ensure organization continuously reduce water consumption through proper environmental management. Finally, local laws like water permits and EIA requirement ensure all designs follow responsible water and environmental standards. In short, this ethical standard guide engineers to balance performance with public welfare and sustainable water use.